right. Can everybody in the back hear me okay at this level? Okay, cool. My name's Wes Milliron. I'm a systems engineer with Giant Eagle, which, if you're not familiar, is a regional grocery retail chain. We have about 400 locations. Feel free to follow me on Twitter, at Wes Milliron. That's 2 L's between the I's. It can be a little hard to see. I also have a blog at blog.wesmilliron.com. Feel free to check that out if you want. So what we're going to cover today, this is the overall kind of agenda. First, we're going to talk about what vSAN is and how it works. And then we're going to talk about some requirements and design considerations specifically for vSAN in general, but then also for vSAN 2-node clusters. And then we're going to talk about what it takes after you design and purchase your hardware, what it takes to actually build a 2-node cluster, and particular gotchas that I experienced as my company went through this journey. As we move through this, anything that's in yellow text on the slides, those are particular gotchas, so to speak. They're lessons that we learned or things that we got bit by as we went through these motions. So just things that hopefully if you go down the same path, you don't run into the same problems. And then the last couple things, we'll talk about some unexpected outcomes that we saw as an organization. And then also I'll provide some resources that were really helpful for me and hopefully will be for you as well. Also, in addition to the yellow gotchas, if you see green underlined text, those are links in the deck. I'll make the deck available on my blog later. So if you, some of these topics, I'm just going to brush on them, but they're pretty deep technically. If you want to read more about it, there will be links provided. So real quick, what is vSAN? So vSAN is a software-defined storage solution. What that means is it aggregates the local disks in your physical hosts to form one large bucket of storage, one large data store for use by your VMs. The beauty of it is it's object-based, but also policy-driven. So instead of defining your RAID levels at your local storage controller or at the LUN on your SAN, you're defining your redundancy and performance levels in policies. And then you apply those policies to the objects on the vSAN data store. And that object is a virtual machine or even as granular as one particular virtual disk. So you can have different performance and protection tiers all on the same back-end vSAN data store. So there's a couple different ways that you can deploy vSAN, and the one we're going to be focusing on today, this laser pointer isn't great, but is the 2-node cluster. It seems pretty intuitive just by the name, but a 2-node cluster can only tolerate one host failure. This obviously, as you guys probably know, isn't the only way that vSAN can be deployed. It can also be deployed as a 3-node cluster, which also only tolerates one host failure, but then also your traditional vSAN clusters, which are 4 or more hosts, those can tolerate 2 or more failures depending on the number of hosts you have and the types of policies that you have on top of those hosts. The way vSAN aggregates the physical disks in a host, it creates what it refers to as disk groups, and those disk groups are logical groupings of physical disks on a server. Each disk group on a vSAN data store has one solid state cache drive and then one or more either solid state or spinning disk capacity drive. Each host is going to have at least 1 but up to 5 disk groups, just depending on what hardware you want to buy. I personally would recommend going with at least 2. Just so you're aware, if your cache disks were to fail on a host, you're going to lose your whole disk group. It's going to be considered inaccessible. So if you only have 1 disk group on a host, 1 drive failure can cause you to lose the whole host. So I'd recommend purchasing servers with at least 2 disk groups. Now we talked about how vSAN is object-based, so everything is stored as an object. Those objects are then broken up into what are known as components, and those components are distributed across hosts in your vSAN cluster. one particular component has a maximum size of 255 gigs. So in this example, there's a 700 gig VMDK. Just by itself, if it weren't protected at all, it would already have 3 components because each one can only be 255 gigs. But then your component count is determined by the policy that you lay on top of it. And that policy defines things like failures to tolerate, which is how many hosts can fail in your vSAN cluster and all the objects are still accessible. And then your RAID type, which is basically defined, is it a mirrored policy or are you getting space savings with parity bits, and kind of like how a traditional RAID functions. And then also disk stripes if you want to add additional performance. So in this example, we have a very typical policy, and this is what you're going to see on most 2-node deployments, which is if you have a 700 gig VMDK and it's configured with a RAID 1 and FTT of 1 policy, FTT being failures to tolerate, this is going to give you 7 total components. We know 3 just based on the size of the VMDK alone, and then we have those 3 are then mirrored by the RAID 1 policy over to your second host. And something that's very important here to remember is there's also that 7th component, which is your witness component, which just contains metadata and helps with object accessibility. 2-node clusters are only going to be able to have RAID 1 policies associated with it. When there's only 2 hosts, there's only 2 spots to write data, so you can't take advantage of like RAID 5 or 6 policies that would spread it across more hosts. That's just something to keep in mind as you're designing your own clusters. Something that's going to come up later, so we're going to talk about it now, is in order for an object like a VMDK to be available, at least 50% of those components have to be accessible by the cluster. And that's the reason why this witness component is important, is because if you were to lose this host in the middle, you still have your 3 original components and then also your 7th witness component. Those 4 collectively are more than 50%, so that is why the witness host in general is critical to the success and operation of a 2-node cluster. It requires that separate witness piece. So what is vSAN 2-node for Robo? Robo just means remote office or branch office, and it is exactly what it's used for. Or what it is named after. It is a 2-node vSAN solution that is specifically catered to those remote offices or branch offices or retail environments or whatever you may have, where perhaps you have a relatively small or light application base that requires HA, but you don't really need a full like 4+ nodes or whatever for kind of a traditional data center vSAN deployment. It's a less expensive alternative to other HA Robo solutions. So maybe at your sites today or historically you've deployed maybe 2 or 3 hosts and a small SAN to offer the same thing. The thing is that, that SAN itself is not expensive. You have the upfront costs as well as maintenance long term. But then also, you have a separate piece to manage. With vSAN, the management of that storage is all in vSphere, all under a plane that you're used to managing today. Again, keep in mind that 2-node clusters do require that separate and external witness host. So now let's talk about kind of the importance of hardware compatibility and what that means to you as you're scoping out your vSAN 2-node clusters. vSAN, like pretty much everything else, leans very heavily on the hardware that it is deployed on. But what this means to you is you really are going to need to leverage the HCL as you're going through these motions. One approach that you can take is you can go out and you can shop for each individual physical component, like your RAID controller and network cards, etc. And you can look on the HCL and verify that it's going to be compatible with the version of vSphere and vSAN that you want to deploy. But you have some other options as well. There's the appliance-like solution, like the EMC VX Rail, which I'm sure some of you are familiar with today. And then there's also the vSAN certified ready nodes, which is where your OEM partner of choice is partnered with VMware, they work together to come up with certified solutions. So they're going to come ready to go, ready to install. This is the route that we chose to take. It was a relatively smooth process. We had some small hiccups along the way as we were figuring things out, but that's the nature of it. It's worth noting here that the vSAN hardware compatibility list is separate from the traditional compatibility list. So those are two different things. So if you want to do research on vSAN hardware specifically, make sure you're using the vSAN hardware compatibility list. It's more restrictive than the traditional one, in that just because you have maybe a traditional SAN-backed cluster today, that doesn't necessarily mean you can slap disks in it and use it for a vSAN cluster. Definitely going to want to use that. Just in the past couple weeks, they actually released a vSAN hardware compatibility checker fling. It's a lot of words, but basically it's a Python-based script that will analyze your current vSAN clusters, and it'll verify that not only the hardware but also the firmware and drivers are listed on the HCL in comparison with your vSphere and vSAN versions. Networking requirements. This looks like a lot of info. It's really not that bad. As far as latency between your hosting nodes, it's limited to 1 millisecond. If you choose to go with a hybrid array, which is a combination of your solid state cache disk and your spinning disk capacity drives, you're gonna need 1 gig throughput. However, if you choose to go all flash, then you will need 10 gig networking. If you're thinking to yourself, oh, well, you say this is for a remote site, but most of my remote sites don't have 10 gig switching. That's okay. There's a configuration method that we're going to talk about a little bit later that can address that problem. As far as latency is concerned from your hosting site to your witness site, it's a maximum of 500 milliseconds. However, it's definitely recommended to be sub 200. Up to 500 is still fully supported. I certainly hope that your two sites don't have that much latency between them. However, I can understand in rural areas that can be a challenge, but it's a requirement and something to keep in mind as you're designing. And then the bandwidth for your hosting site to your witness site is 2 megabits per 1,000 components. Each host has a 9,000 component max, so it's not going to exceed the 18 meg throughput. It's not too demanding, but chances are if you're maxing out your component count on a host, then you probably have a demand that would beg for more than a 2-host solution. So vSAN is baked into ESXi. It's part of vSphere. So its version corresponds with, the vSAN version corresponds with the vSphere version. For vSAN 6.6 and later, unicast is fully supported all the way across the board, which is nice and easy to work with. And that comes with ESXi 6.5, and this is kind of probably a hard to read table that correlates vSAN versions with vSphere versions. This is not a complete list. This is just everything that supports a vSAN 6.6 and later. I would, at this point, ESXi 6.5 is, I think, about 2 years old. I certainly hope that that's not the level that you're still deploying. If you're having earlier versions than that, then you're going to run into multicast requirements, which just adds some complexity to your design. So I definitely try to avoid those earlier versions. So let's talk about that cluster witness a little bit more. So there's a 1-to-1 ratio of cluster to witness. So if you're going to deploy this to 10 different sites, you're going to need 10 different witness appliances. There have been a lot of customers asking for one witness being able to handle multiple clusters. Let's hope we see that in the future, because that can be, if you're deploying this, for instance, if we want to deploy this to all 400 of our locations, that's suddenly a lot of witness appliances that we have to maintain. The witness's job is to maintain quorum and data accessibility of the cluster. We talked before how it contains the witness components, and it maintains quorum, so in the event of the host become partitioned, it acts as a tiebreaker. The witness host does not contribute any compute, memory, or storage to the cluster itself. It's simply there for quorum and accessibility. VMware offers a witness OVA that you can download from their website, and this is the method that we chose to employ, and I would definitely recommend going that route. If you didn't have a separate data center that you were able to host a virtual appliance in, you can run it on a separate physical host and it'll function just the same. But that does give you, now you have another piece of hardware that you have to maintain. So I would definitely recommend going the OVA route if you're able. So we talked before how vSphere and vSAN are kind of baked together, but they need to be licensed separately. So each cluster is going to require 2 licenses, one for vSphere and then one for vSAN. To make this a kind of a more affordable option, VMware offers what it refers to as robo licenses. Those robo licenses have a 25 VM maximum, and that VM count is also how they're consumed. So if you had 10 sites, but say for example you only had 1 VM at each one of those sites, you would only need 1 robo license, and that would apply across the entire environment. It's not tied to core count or physical hardware. It's consumed by the VM count, which is really nice. Now this actually changed a little bit today. So before this morning, if you want to use DRS, it required a vSphere enterprise license. Notice that is not a robo license. However, they just announced this morning that 6.7U2 is going to be out shortly, and they also announced a Robo Enterprise license, and that's a vSphere Robo Enterprise license. That does include DRS, and it's presumably cheaper than a full vSphere Enterprise license, but I don't know what that looks like. A couple things to keep in mind here, that if you want to use deduplication and compression, you're going to need at least an advanced license. Dedupe and compression requires an all-flash configuration, but if you want to use those features, you're going to need at least an advanced license. That's whether you go either robo or non-robo. And then if you want to use data at rest encryption, it's going to require an enterprise license. Again, whether you choose to go robo or not, that still requires enterprise. So that's pretty much all of the requirements that you would have. So now we're going to kind of bring all that together and ask ourselves some questions to pull all these pieces together. Usually you start out by asking yourself, okay, what's my budget for this project? Most customers, that's usually their limiting factor, is I have X amount to spend. What can I do with this? If you work for a company that doesn't have budget restrictions, let me know if you're hiring. But the second question you usually find yourself asking is, what are the networking options I have at my site? Like we said before, do we have 10 gig networking available? If the answer to that is no, is it in the budget to deploy it? Maybe, maybe not. But there's also 2 node clusters can also be configured in a direct connect scenario. So that is when the 2 hosts, their vSAN traffic specifically, they're directly connected with Cat6a Ethernet cables. And this is what we chose to employ, because our warehouses where we deployed this, we either didn't have 10 gig networking at all, or we didn't have enough ports that we could do what we needed to do. So we just said, we're just going to skip that, and we're just going to direct connect these hosts, and it works just fine. And then another thing you're going to ask yourself is, where am I going to store these witnesses at? Do they meet the networking requirements that we talked about before? Then next, you're going to plan for capacity. So whether or not you go hybrid or all flash, those 2 node clusters are limited to mirrored storage policies. You can optionally elect to do a RAID 0 policy with no redundancy. I wouldn't recommend that for obvious reasons. But the best that you can get is a RAID 1 or mirrored policy. But what that means is your storage multiplier is 2x. So a 100 gig VM actually is consuming 200 gigs on the storage side. So as you're, if you're saying, well, maybe we're going to have 4 terabytes or whatever at this site worth of data. that's all the disks we need to buy. That's not true. You're actually going to consume twice as much as that for protection. A couple things to consider when you're looking to buy your hardware. So maybe your driving factor here is your budget. If you need to go as cheap as possible on your build. The cache drive, which has to be flash, is a fairly expensive component when you're looking at the server as a whole. If you're looking to drive costs down, you can size that drive to be smaller. However, that needs to be at least 10% of the consumed storage space by the VM. That's a little bit complicated, and sizing it exactly right doesn't really give you a lot of room for growth. I wouldn't recommend that if you don't, if you're really pinching pennies, sure, that's fine, but I wouldn't recommend doing that. On the other side of that, the write buffer on your cache drive is limited to 600 gigs total. Now that doesn't mean that, I never need to buy more than a 600 gig drive. Let's say you were to buy an 800, if you got a ready node and it came with an 800 gig drive, that's completely fine. The nature of flash, that extra 200 gig is just going to be used to expand the lifespan of the drive itself. That being said, maybe purchasing a 4 terabyte cache drive is a little excessive, but again, just something to keep in mind as you're going through these purchasing exercises. As far as where you're going to install ESX, you have a couple of different options here, just like you traditionally would. You can go with a SAS-based disk or an M2 drive, which is what we elected to do, or an SD card. As we know, SD cards aren't considered persistent disks, so you can't flush your logs to an SD card. However, you also don't want to store. You also can't simply just redirect it to the vSAN data store, because if there's a problem with the vSAN data store, which would cause those flushes, there's no destination for those logs to live. So that's why I would recommend going with a persistent disk like an M2. You even have a PCI-based drive if you like. But if you go with traditional drives or an M2 or whatever, and you want to run mirrored drives for ESXi, you should run those on a separate RAID controller than you're running your vSAN disks. vSAN disks need to be configured in pass-through mode on the RAID controller, and you don't want to run pass-through disks and RAIDed disks on the same controller. That's referred to a mixed mode configuration, and generally that's not recommended. So that's not, when we first started this journey and we started to learn about these requirements, that was never something that I would have anticipated myself. So I hope that someone in here gets something out of that. As far as when you're thinking about your design of your network, there's not a whole lot to consider here. You can choose to configure the networking using a distributed switch or your standard vSwitch. If you use a distributed switch, you can optionally enable network I/O control, which can be useful in a non-direct connect scenario if you needed to add QoS on top of your vSAN traffic. It also allows you to use link aggregation groups if you wanted to go that route as well. However, if you choose to, and I would recommend going with the standard switch. That's what we did. It makes it easy to manage and deploy. It'll make your life easier. However, if you go with a standard vSwitch, one benefit of that is it does give you some increased portability. If you need to move the cluster from one vCenter to another vCenter, the DVS is tied to the vCenter itself. So if you're planning that in your future, maybe you build it, initially as a standard switch and cut it over later. Everyone's environment is going to be a little different, but just a couple of things to keep in mind. So we talked about what the requirements are and what we should be thinking about when we're designing these. But now we're going to real quickly talk at a high level about what it takes to actually build and configure one of these clusters. We're not going to get too deep in the weeds here. We're just going to talk at a high level, and I'll be mentioning lessons that we learned along the way, so you won't get caught in the same traps. So as far as building your ESXi host, really not a whole lot of crazy stuff here. You're going to build your host using all your standard practices that you're doing now. But again, you want to configure your RAID controllers for your vSAN disks in pass-through mode. If for whatever reason your controller doesn't have a pass-through mode, you can also configure the disk as RAID 0, and that'll work just fine. Also on the RAID controller, if it is capable of any write caching, you're going to want to disable that. vSAN handles the caching in the software, and if the RAID controller is doing it separately, that can cause problems. So you're going to want to disable any write caching at the RAID controller level. Last couple things seem really simple, but there were some people along the way who maybe forgot to do a couple of these things. Obviously, you're going to have a heck of a time moving your VMs around if you forget to enable vMotion. And we've all seen scenarios in our environments where if you don't have NTP configured properly and consistently, it can cause issues. vSAN's no exception to that. Definitely going to want to make sure you have a properly configured and consistently configured time settings across your cluster. Same for syslog as well. So as far as actually creating your distributed switch, not a whole lot you need to keep in mind here, just the number of uplinks that you're going to configure, which would be determined by the ports that you're going to use on your host, and also whether you're optionally going to choose to enable a network I/O control. After you have your distributed switch configured, you're then going to create at least 2 port groups on that distributed switch. You can obviously create more if you want to, but you're going to need a minimum of 2. One will be for your management traffic, and one will be for your vSAN traffic. These screenshots are showing a configuration for a direct connect scenario. And we can see that because the vSAN port group is configured to use uplinks 3 and 4 and not 1 and 2. And then the opposite is true on the other side, where only the first 2 uplinks are used and not 3 and 4, which are used by vSAN. If you were to add additional port groups for more VLANs or whatever, you would configure it similar to the management port group in this example, because those uplinks 3 and 4 are reserved specifically for vSAN traffic. Last thing to pay attention to here is the load balancing mechanism that's used by the vSAN port group. Unless you're choosing to use a lag group for this traffic, this isn't going to gain you anything no matter what you change it to. vSAN by its very nature is only going to use 1 uplink at a time, even if you have 2 configured to be active here. So you don't, you may think, oh, I have 2 configured active adapters. It doesn't matter, it's not going to use it. So just a little fun fact. After you have your port groups created, you're going to need a VMK, a VM kernel adapter, on each one of your hosts. That VMK is dedicated for vSAN traffic. And hit the button. So obviously, don't forget to enable the vSAN service. vSAN's not going to work super well if you don't enable the service on the VMK. VMware doesn't recommend changing the MTU size unless you have a very specific case or reason as to why you'd want to do that. It introduces some complexity and it doesn't really gain you a whole lot, especially in a 2-node environment. So all of these steps, as you can tell, they're really not that complicated, and the witness deployment isn't really complicated either, but of all the steps, this is probably the one that requires the most, oh, okay, yeah. So vSAN has a requirement that the management traffic and the witness traffic have to be on separate subnets. If at your remote site, maybe it's just a flat network with no additional VLANs, you can basically just create like a dummy VLAN essentially in a direct connect build and assign it any private IPs that you want. But when you deploy the VRA, the virtual appliance, at your witness site, all it's going to do is you're going to walk through the wizard, and it's going to ask you all the standards, set the root password and yada yada. After it's deployed, you're basically just going to have a virtual ESXi virtual machine running. You're going to need to log into that, set the host name, and all the stuff as you normally would. That's really all it is just a virtual ESXi host. Once you have that deployed and configured with its IP and host name, you then need to add, all you have is a virtual machine running ESXi in your data center. You then need to add that host to vCenter so it functions like a host. Last step for it is to then modify the vSAN VMK on the witness appliance to override the default gateway. So you're going to configure this this VMK on the witness. You're going to give it a static IP, but for some reason, by default, the witness traffic coming from the witness it will get rerouted and use the management network. This will confuse your hosting nodes because they are expecting to see that traffic to come from its configured witness network. By default, this checkbox, override default gateway for this adapter, is not checked. So you're going to check that box, set the gateway for the subnet that it's on, and you'll be good to go there. Last steps here, you'll create your cluster object in vCenter. Something to note there, when you create the cluster, you want to have DRS and HA disabled. That will effectively be the last step of the deployment. Once you have the cluster created, you'll drag your host into the cluster, and then you'll go into the cluster configuration and enable vSAN. There's nothing additional to install. Remember, vSAN is just part of the ESXi code. So you'll enable the vSAN service, and that's going to bring up a wizard. At that point, it's fairly straightforward. 2-node cluster next, and then there'll be a screen. You can optionally choose to enable dedupe and compression if you have an all-flash array. Here is also where you would choose to elect. This is a little blurry, but you can optionally turn on encryption if you have that requirement. The next step of the wizard is where you're actually going to claim your vSAN disk. The wizard does a pretty good job of detecting what it thinks should be your cache drives and your capacity drives based on drive type and capacity and whatnot. However, if you're kind of a stickler like we were, we wanted our disk groups to kind of look like this, where the top row of disks in the physical server was disk group 1 and the bottom group was disk group 2. However, we ran into a problem where the wizard doesn't show you the physical drive bays, or like the location of the disks on those hosts. All it gives you is the NAA IDs. So at the time, we had to come up with some, we had to figure out how to run the HPE Smart Storage Administrator like command line utility in order to find values where we could associate those NAA IDs with physical drive bay location. Fortunately, it's a little bit easier now. They recently published a code sample that will help you do that in your environment. It's a lot more elegant than the kind of crappy one that I had to throw together. But it'll help you with that if you want to be particular. But again, if that's not something that you care about, as long as you review and confirm the configuration's good, probably the defaults are going to work out for you. Last step of the wizard is where you're just going to select that previously deployed witness appliance that you added as a host. You're going to say this is going to be the witness for this cluster. At that point, you're going to hit finish. It's going to pull the disks together and turn on vSAN, and you're going to be very nearly ready to go. If you did choose to go with a direct connect configuration, there is an extra step that you need to run. So kind of the opposite is true on your hosting nodes, where the witness traffic wants to travel over the vSAN network. In a direct connect scenario, that vSAN network has no way to talk to the witness appliance. So you have to reroute that traffic using this command to do that, so that you'll take that witness traffic and instead of routing it over the vSAN network, to move it over the management network. That will then allow the witness traffic to flow properly so everything can communicate. Now, this command was for my environment where VMK0 was the management VMK. You would change that for your environment. This whole thing that we're talking about, this rerouting this traffic and whatnot, it's known as witness traffic separation. It's a pretty deep topic in itself on when and how you would use it. We'll go over some resources later where you can do some more digging on that. After you run that on each host, not on the witness host, just on your hosting nodes, then you can do some quick troubleshooting and confirming that you did everything right with VMK ping, where you can ping traffic just on the vSAN network, or from each host to the witness site, or the witness site down. This is going to kind of just give you a high-level view of whether or not this is communicating properly at all. Your finishing touches after you did all that are basically, remember, vSAN cluster has to be licensed separately, but you can't actually assign that license until vSAN is enabled. So once you have all the previous steps done, you're going to want to go back in and assign the license to the cluster. And then here is when you would enable high availability and optionally DRS if you're licensed to do so. You can pretty much accept all the default HA settings with the exception of admission control. VMware recommends reserving 50% of the compute and memory resources in the admission control settings. That's, for some reason that I don't quite understand, that is not the default calculated percentage. However, it is the recommended configuration, and that's not by default, so you need to set that separately. Data store heartbeating is not enabled by default on vSAN data stores. That would require some additional, it's not available at all in direct connect clusters. In non-direct connect clusters, it requires some additional consideration and configuration, and there's plenty online to read about that. Last step would be patch the clusters. Obviously, you're going to bring it up to whatever your latest supported version in your environment is. But if you don't have DRS, which we don't, just due to the licenses, your VMs need to be manually migrated around in order to get your hosts into maintenance mode. Those hosts, your hosts in the cluster and the witness all have to be patched to the same level. So these commonly get referred, our 2-node clusters. We got to patch our 2-node clusters. You're actually patching 3 hosts here because you're patching that 3rd witness host. And then after you go through all those motions, with certain releases of vSphere also come a new on-disk format version for vSAN that occasionally gets released. That's effectively the same as your VM hardware version. It's just on the vSAN side and exposing that latest capabilities from the storage. After you're all said and done, you're going to want to go to your vSAN Health Check, which is under the Monitor tab on your cluster. Hopefully this is the screen you see where you see those green check marks that we crave as an industry. However, if there were any issues, if vSAN detected any problems with the configuration, it would show those problems here, and you'd be able to drill down and identify exactly what the issue was that it was seeing. And in some cases, you're able to automatically remediate those problems. If an object hasn't resynchronized properly or whatever, there's a button you can tell it to do that right away. Also, cut off from this screenshot, you also have the option to run an online health check. And what that does is that sends the vSAN telemetry data up to VMware, where they kind of do their magic and they compare it with their current best practices and information on the HCL. It does more of a comprehensive check. That does require internet connectivity, so that may or may not be an option for you, but it is really nice to run. So now I'm going to talk about how you can take your built clusters and get them out in the field. Obviously, everyone here is going to have their own way of, well, this is how we typically handle that, and that's fine, and you can continue to do that. But generally speaking, there's 2 approaches. Are you going to build them at a central location and then distribute them to their remote sites? Or are you going to ship the hardware directly there and either configure it remotely or have a set of remote hands or somebody at that location take care of it? What we chose to do, we had the luxury where all of our warehouses that we were deploying this to were within a relatively short drive. So we had all the hardware shipped to our headquarters where we staged everything and then delivered it to the site. We brought it in-house, built everything up to spec. And then right on delivery day, we logged in, changed it to the static IP of the destination site, shut down the hosts, updated DNS, literally just drove them out to the site, racked them, hooked them up, turned them on, and walked away, and it was completely fine. Really smooth deployment. If I understand that's a luxury, sometimes your sites are hours and hours away, and that might not be an option for you. If it is, we had a really smooth deployment this way. Regardless of which approach that you take, I cannot emphasize enough the importance of documenting this. And I know documentation is kind of a swear word, generally speaking. but it's really, really important, and it's going to be critical to the success of the deployments that you do. And just to illustrate that a little bit, here's just kind of some examples of some documentation that we took. And the detail of what the text says here, it's not important. I realize it's probably hard to see, but really it's just what I'm stressing here is kind of the level of detail that we took. We took pictures of the backs of the servers, and these ports are used for vSAN traffic, and these ports are used for everything else. And what VMNIC value was assigned to what actual physical port on the server. These steps over here are if you were to manually deploy the witness appliance. It's screenshots of every step along the way and things that you need to enter. Again, the actual contents of these slides, they're not important and they wouldn't necessarily apply to your environment, but the important thing to remember here is the level of detail that you should be going to with your documentation. You want to be able to walk away from these environments at the end of the day, and the only way to do that really is to give something to your team so that they can manage these moving forward. So real quick, now I just want to talk about some unexpected outcomes that we had. So when other infrastructure teams who traditionally we wouldn't really work together, I wouldn't say there was a culture of distrust, but it was more along the lines of, well, we know what's best for our team. We're going to do things our way. We can let everybody else do what they want to do. We have struggled traditionally with strong organizational silos, which have been a problem. But when other teams were noticing that we were really kind of approaching this the right way and doing all the steps that we needed to do and spending maybe more time than we needed to getting this right, they said, hey, that's actually, that's really valuable. Maybe for our deployments moving forward, maybe we'll leverage this. But regardless, we're starting to have conversations now where we're aligning our design strategies for hardware and how we configure it and get it out into the field. That was obviously not something that we planned on when we started this project, but now we're seeing infrastructure teams come together within our organization, which is something that hasn't happened before. And I just threw on there, do it once, do it right. This is a lot of homework that you have to do, especially when it comes to your purchasing and your configuration. Spend the time, do it the right way. You don't want to be spending a whole lot of time managing these moving forward. These should be as easy to manage as your traditional vSphere environments. Have a couple resources here for you. Hopefully you guys by now are familiar with storagehub.vmware.com. That's all things vSAN, all things SRM, all vSphere storage. There's a portion specifically for 2-node clusters with a lot of really good information, so I'd recommend checking that out. And then just some examples of some really good blogs that I found helpful were the VirtualBox blog on the VMware site, and then Cormac Hogan's blog as well. And depending on what you want to learn about, they've written about everything there is to know about vSAN. If you want to learn about the algorithms that are used to calculate this and that and the other thing, they have the math on their blogs. It's really impressive. And then shameless self-plug, there's also my blog that you can go visit. I have a couple posts related to some specific problems that we face through our deployments and how we overcame those. Regardless, I think something that's important here is no one resource is going to be able to answer every single question that you may have along the way. So do your research. Check out all the sites you can, check out all the blogs of everybody you know, but also lean on the V community. That's something that I've found to be incredibly valuable over the past year or so. There's a lot of people who they know how to do this stuff, they've done it before, they've been in the trenches doing these deployments. They're gonna wanna help you get out of the trenches. I've never had an experience where I've reached out to somebody and they say, no, I'm not gonna help you, or there's nothing I can do. Use those people, reach out on Twitter. There's conversations going on every day about that stuff. So don't hesitate to do that. That's everything that I have for today. Again, you can follow me on Twitter or check out my blog. I'll be around for a few minutes. Does anybody have any questions that they want to bring up? Yes?
So I'm kind of curious the ongoing maintenance of these clusters that you have dispersed in sites. Now granted, you said that they're drivable, so maybe that helps. But the thought I had is, okay, so you have 2 nodes, you take one down, and now you're in kind of a weird data risk situation, right? Because whatever kind, depending on the outage you would have when one of your hosts is down, you're in data loss territory.
Absolutely.
So then thinking about, okay, well, you know, one of the things that tends to be an ongoing problem with servers is just the dang firmware, drivers, etc., is especially more sensitive for vSAN.
Absolutely.
So how do you kind of mitigate that risk to the data loss? Is the data that is residing on these vSAN clusters maybe not as big of a deal if it were to be lost? Do you have a recovery strategy that, hey, crap, this host has to stay down for a while because the firmware just totally toasted the server?
Right.
Obviously, in a multi-node cluster, wouldn't be as big of a deal. So just
no, that's
frame the question.
No, it's a good question, and I would say the answer is multi-pronged, if you will. Obviously, I think the first answer to that question would be if you have something that is critical enough that you could not afford that in any way, then perhaps a 2-node deployment is not the right deployment for you. That's one consideration. Is obviously make sure you're designing your solution around what applications are going to be living on it, and how the business requires those to be available. The other side of that is, I would say, by doing proper design, you can kind of, I wouldn't say like self-mitigate, however, but like if your hosts have 2 disk groups, you're already right there, you have a little bit additional redundancy for hardware failure. So you're saying in a scenario where you're patching one host maybe, but then you have hardware failure on another host. Is that, yeah, that's obviously a problem, and in a 2-host scenario, there's only so much you can do. But you can build additional redundancies in your physical hardware design, as well as, what else was I gonna say? Let me think. I could talk to you specifically, but I think my overall answer would be, yeah, you wanna design your cluster appropriately. There's also I remember what I was gonna say. There's also the, I think it's like the cluster object repair timer, I believe, which by default is set to 60 minutes. So you would effectively have 60 minutes of downtime in this scenario to be able to fix whatever problem was caused, and then assuming you were able to get that host brought back up inside that window, you would then, you wouldn't really be suffering any data loss other than if you, other than any like writes that had not yet been flushed to your capacity disk. I think at that point you would have lost any pending writes in your cache drive. But in that setting, that timer, it can be adjusted to longer than 60 minutes. It's an advanced setting somewhere in vSAN. And some customers are setting that to 2 hours or maybe longer, how they, long enough that they feel that they can get the host repaired and bring it back in. Does that answer your question?
Yeah, kind of. I mean, like the one thing with the sensitivity of the data, your tolerance to loss, maybe you do a bigger cluster.
Right.
Therein lies the challenge, right?
Right.
Because what are you doing? You're doing this for remote sites where you're trying to keep the cost low. It's got a low VM count. If you've got 2 VMs or 3 VMs, and now suddenly you have a 3 or a 4-node vSAN cluster, you really have to start going, what the hell am I doing?
Right, and
so that's where our challenge has been with vSAN, is that it's hard to really see if it, if it really is the right.
Yeah, and it's
at small scale.
And it certainly has its limitations, right? I'm not going to sit here. I don't work for VMware. I'm not going to sit here and tell you that this is the best thing and it's going to be the perfect fit for every environment you have. It certainly has its limitations. We just found that we were running domain controllers, file print servers, and then some local applications at those warehouses. It wasn't anything ultra critical. I think if I were in your shoes, and I understand that this isn't the case for everybody, if you have really critical information on there, then there's a business case to be made to either have a 3 or 4 host cluster, or at least employ maybe a stretch cluster from your remote site back to any other site, if you have those options. But again, everyone's scenario is a little different.
No, I appreciate that. Like I said, just wanted to kind of
yeah, no, it's
what your
No, it's, yeah, this is not a,
Make a decision, right?
this is not like a, this is not a one-size-fits-all thing. It has its use cases. It works great for us, and I think in a lot of cases it can be the right fit, but it's not always the case, right?
Yep.
Anybody else? Cool. Well, couple minutes. I think there's some beverages that are waiting in the other room, so I'm not trying to keep anybody from that. So, thanks, guys.